All right, so here we go, class. Once again, this recording is to help you understand your MATLAB assignment number 2. So we learned last time that partial pivoting is used to help, computers use it to help reduce round-off error in solving a system of equations. With partial pivoting, you want to use the largest number in the column as a pivot. So the LU fact, but in order to do that, you need to allow for row interchanges. That's what section 2.5 mentioned above the numerical notes about permuted LU factorization. So what we're doing now is we're taking L times U. Well, no, we're taking a matrix A and we're going to multiply it by what's called a permutation matrix P. P times A will equal L times U. Okay. So if I go to the next page, you notice I have three. Hold on, let me get this. All right, I have E2 times E1 times A. Now, the matrix A, we want in the matrix A here the number 4 in the first column to be the pivot. So we want that to go to the top. All right, to use as our pivot to produce zeros in the first column. Well, that means in order to do that, we want in matrix A, we want the first and third rows switched. We want to do a row interchange. Well, to do that row interchange, what we do is we multiply the matrix A by an elementary matrix, by the elementary matrix E1. Okay, and E1 here is right here. So this elementary matrix E1 that I'm circling, notice what it is. If you take the identity matrix and switch the first and third rows, you're going to get this elementary matrix E1. So look, if you take E1 and multiply it by, now don't worry about this bracket. You'll notice there's a bracket here, right? I want you to ignore that bracket for right now. Okay, what I want you to do is focus on the matrix product E1 times A. E1 times A is this part, right? E1 times A is this part. E1 times A is going to equal this matrix here. And you notice this matrix here, which is E1 times A, is simply the matrix A with rows, the first and third rows interchanged. Okay, and that's what we wanted because now the 4 is the largest number that we can use as a pivot in the first column. Okay, now what we want to do next is we want to interchange. Well, we look at the second column here, the 3 and the 4, and the 4 is the number we want to use as the pivot because it's larger than 3. So that means that we have to switch the second and third rows. We have to do another row interchange. Okay, along comes matrix E2, which is up here. Okay, matrix E2, okay, right here. Again, that's just the identity matrix where rows 2 and 3 are interchanged. So, all right, if you take matrix E2 times E1 times the matrix A, okay, if you take E2 times E1 times the matrix A, you're going to get this matrix here. Okay, so this is E2 times E1 times A. And you'll notice now the 4 in the second column is right where we want that pivot to. We want that, the largest pivot, to be right there, and it's there. Now, the product of these two elementary matrices, E2 times E1, okay, is called P. And that's known as a permutation matrix. So if you look up here, this red matrix, this matrix here I'm circling, that's the P matrix. That is E2 times E1. And all the permutation matrix is it's just, it's the identity matrix where you're switching around the rows. Order does matter, David. We have to do E2 times E1 times A in order to get the matrix in the form we need it in, where the largest pivots are where we want them. Yeah, you're not going to do E1 times E2 times A. You're going to do E2 times E1 times A. And that equals this P times A. David, is that okay? I am not certain about that. Matrix multiplication is not commutative. So I don't believe if you did E1 times E2 times A, I got to be careful. You might be seeing something I'm not seeing. I'm not saying you're wrong, but I know, I mean, I try to be very careful before making a generalization. I'm just doing the row operations in the order that I want to do them, you know, for the forward phase of getting of getting the pivots where I want them. And you know, so, but all right, so now I'm going to do LU factorization on this matrix here, on my permutation matrix times the matrix A. And again, the permutation matrix was just found by taking the elementary matrix E2 times E1. So if we go now to, and Michaela, hopefully that made things a little more clear. Thank you for, hopefully that's a little more clear for you. Okay, excellent. You're welcome. Okay, so here we have, okay, here we have our P times A. And this is, we do LU factorization on P times A. So you know how this works. You know how this works. You have to do the necessary row operations. So if we take -1/4 times row 1 and add it to row 2 and put the result in row 2, and if we take -1/2 times row 1, add it to row 3, and put the result in row 3, okay, then this is the matrix that's going to resolve. And then notice what I did. I'm creating the lower unit triangular matrix at the same time. So what I did was I took the first column, 4, 1, 2, you know, up here, the 4, 1, 2, and divided it by 4. And you're used to doing that. That's in the algorithm. Right? All right, all right, great. So for the first step here, I was able to use 4 as my pivot to get the matrix in this form. And now I'm going to use 2 in the second column as my pivot. So I want a -1 where the 0 is. So of course, what we have to do is we have to take then 1/2 times row 2, add it to row 3, put the result in row 3. And that's going to give you this matrix here, and that's an echelon form. And a little note here that 2 row interchanges had been used previously. All right. This here, I want to be a little careful. This means I'm not sure I even need this note, okay? Because we didn't do any row interchanges here, right? It's just to get the matrix P times A involved 2 row interchanges on A. So, all right. So, here we are. Here's that 2, -1. Divided by 2, here's the -1.5, divided by -1.5. And now, here is our matrix L. So we have the matrix L, the lower unit triangular matrix L. And we have the upper, or the echelon form matrix U. So this means then that P times A equals L times U. Now in MATLAB, what you're going to do, and they talk about this in MATLAB assignment 2, the first exercise, you're going to figure out what, using MATLAB, you're going to use the LU command, okay, on the matrix A. So now I want to be careful here. This is MATLAB. Now what I'm mentioning here. So let me kind of separate that out. This is MATLAB command. MATLAB, you will use the command LU of A. That's going to do an LU factorization that will generate a matrix L, a matrix U, and a matrix P, like the ones that I've shown you in this example. The matrix P, just for the reference, the matrix P from the previous page, that permutation matrix was 0, 0, 1 on the first row, 1, 0, 0 on the second row, and 0, 1, 0 on the third row. So what I want to do is I want to go into MATLAB, okay, for this example, do this command and see if MATLAB gives me U, L, and P. Okay? Are there any questions? Any questions at all? Okay, let's go to MATLAB. Let me bring up MATLAB. You bring up your MATLAB too. And type in that matrix A. Type in that matrix A. I'm waiting for my MATLAB to come up. Hang on. Okay. Get that one off. Okay. Close this out. Let me just. Okay, this is fine. Let's see. In we go. In we go to MATLAB here. Okay, and oh, how do you make a matrix? Okay, no problem. Here's what you do. A equals, all right, the first row is 1, 4, 4. Use a semicolon. Second row is 2, 3, -1. Another semicolon. You use semicolons to separate the rows. And then 4, 8, 4. Okay, let me turn off my email here. I don't want any distractions. All right, so let me get that email off there. Okay. Let me see. We're still. Hold on here. I got to make sure we're. Yeah. Okay. Great. So, all right. Left bracket. I guess that's bracket. Sorry, like that symbol there. L comma U comma P equals LU of the matrix A. This is MATLAB's matrix factorization, LU factorization. Okay, and here are our results. So, okay, does the matrix L match our matrix L? If we go back here, hold on. Okay, our matrix L is right here. Does that matrix L, so look at matrix, look at U, look at L, and look at P. Okay, those three matrices. When you do the LU factorization in MATLAB, okay, do the LU and P match what we just did? Okay, Mikhail says yes. Anybody else? Please let me know if you're not understanding. What I'm trying to do here, all right, Marcella's seeing that. Yasin, all right, it's clear. Good, good. That's what I want. Good, thank you. Thank you, David. Thank you, Belen. Excellent, excellent. So now you know what's going on with the LU factorization in MATLAB. And there really is a very nice quality that, I mean, we can really use this permuted LU factorization to help us actually find the determinant of a matrix A. And let me show you how. Let me show you how here. So okay, so we did the LU factorization. And let's take a look here. Now, well, you're right, Mikhail. we know that P equals P times A equals L times U. Okay, we know that for our example. And we can take the determinant of both sides of that equation. Okay, P times A is a square matrix, L times U is a square matrix. If we take the determinant of the left side, we have to take the determinant of the right side. But by properties of determinants, the determinant of P times A is equal to the determinant of P times the determinant of A. On the right side, the determinant of L times U is the determinant of L times the determinant of U. Well, the matrix P, okay, if you do the determinant of P, you're going to get a positive 1. But you can think of the positive 1 as like negative 1 to the second power, where that second power is there because 2 row interchanges were needed. Okay? 2 row interchanges were needed. Okay, so that's one of our rules that we learned for determinants, right? When we do a row interchange, it introduces a negative 1 in computing the determinant. So now the determinant of L is lower unit triangular. So the determinant of L would just be the product of the diagonal entries, which are all 1s. So you get 1. So this means then that the determinant of A here, the determinant of A is equal to the determinant of U over negative 1 squared. But negative 1 squared, you can just bring that to the top. That's not a problem. And so you have in other words, this is how MATLAB can compute a determinant, right? It's a nice, how it so what you're going to do in MATLAB assignment number 2 is you're going to use the MATLAB command determinant of A. You're going to use that command. Okay, that's the MATLAB command. You're going to get a determinant of A, but then you're going to do the LU factorization, the permuted LU factorization in MATLAB of the matrix A, and verify that indeed the determinant of A equals the determinant of U over, well, the determinant of P. Okay, so let me just redo this. Hold on one thing here. So, I mean, basically here, from this equation, we can say that the determinant of A is equal to the determinant of L times the determinant of U over the determinant of P, right? But of course, the determinant of U, I'm sorry, the determinant of L is equal to 1. So you're going to, in MATLAB assignment number 2, you're going to compute the determinant of A using the MATLAB command determinant of A, but then you're going to verify it by doing the LU factorization of A and working out this here. It's just just doing it on just doing it all on MATLAB, but it's just a way to understand what's going on. Are there any questions on that? That's MATLAB assignment number 2, exercise 1. That. Okay, are we good with that? Are there any questions? Okay, Yasin's good. Cameron's good. Great, great. Yeah, you have, Mikhail, you have the knowledge to do, you have the knowledge now to do MATLAB assignment, the exercises in MATLAB assignment number 1 and the exercises in MATLAB assignment number 2. You have the knowledge now. Yes. Okay, great. Well, let me stop the recording. Yeah, it is nice.